Welcome to qnawire.
In this question, it is given a pendulum is hanged inside an elevator. The mass of the bob of the pendulum, that is, let's say denoted by m, that is given as 50 gram, which I can write as 5 into 10 power minus 2 kg. Okay. Now, this question has around 6 parts. In different cases, either the lift goes upward or downward with some acceleration or some deceleration. In each case, we have to find the tension force acting on the string. So let's first solve the part A. In part A, it is given that the lift goes up with acceleration. Let's say that is A is equals to 1.2 meter per second square. So I can just denote that by A in the upper direction. Okay. Now on the bob, because of the movement of the lift, there will be a pseudo force acting in the opposite direction of the motion of the lift. So ma force will be acting downward. At the same time, the weight of the block, that is mg, will be acting in the downward direction. A tension force will be acting on the bob in the upward direction, which we have to find in this case. So for equilibrium of the bob, I can write for equilibrium of the bob, I can write the net upward force will be balanced by net downward force, which will be ma plus mg. If I put the values, I will get T equals to m, which is 5 into 10 power minus 2 kg, into a plus g. A is 1.2 and g I can take it as 10. So on simplifying this, this will be approximately 0.56 Newton. So here I have assumed that G is 10, so that's why I'm getting the tension force on the string as 0.56 Newton. Okay. In part B, it is given that the lift or the elevator goes up with deceleration of 1.2 meter per second square. That is, I can write the deceleration as A, that will be minus 1.2 meter per second square. This minus sign imply that the object is having some deceleration, the lift is having some deceleration. Okay. So in this case, basically the object is decelerating in the upward direction. So that is with an deceleration of 1.2 meter per second square. This is equivalently, we can say that the object is having some acceleration downward. So in this case, the pseudo force that will be acting in the opposite direction of the acceleration of the lift, so then we can say that the pseudo force on the block will be acting in the upward direction, that is m into a. Here we have to only take the magnitude of the acceleration, because this a over here is representing the acceleration of the lift. So once again, as the lift is having some deceleration in the upward direction, we can equivalently say that the lift is having an acceleration in the downward direction. So if the lift is having an acceleration in the downward direction, so the pseudo force will be acting in the upward direction. Okay, any other force acting on the bob? Yes, mg force is acting downward, and again the tension force will be acting in the upward direction. So in this case, again, for equilibrium of m with respect to lift or elevator, we can write that T plus ma has to be equal to mg, or the tension force on the string is going to be equal to m into g minus a. So if we put the value 55 into 10 power minus 2, sorry, 5 into 10 power minus 2 into g is, we can take 10 minus a is 1.2. So this is going to be approximately 0.44 Newton. So this is the answer for the second part. The tension force on the string is 0.44 Newton. In part C of this question, the lift or the elevator moves upward with uniform velocity. So if the velocity is uniform, that implies that acceleration of the elevator A will be 0 because the velocity is uniform. So we can just write that A is equal to 0 over here. Then with respect to the reference frame, which is the lift, on the bob, the forces those are acting is mg downward and tension force upward. So then by applying Newton's second law for the equilibrium of the by applying Newton's first law for the equilibrium of the bob of mass m, we can write that the net upward force has to be balanced by net downward force, which is m into g, the weight of the bob. So m is 5 into 10 power minus 2, g is 10. So this is going to be 0.5 Newton. So this is the tension force on the string. Now whenever the lift or the elevator is moving upward with a uniform velocity. In D part of this question, it is given that the lift is moving downward with an acceleration of 1.2 meter per second square. So we can just write elevator moves downward with acceleration a equals 1.2 meter per second square. As in this case the lift moves downward, so on the bob a pseudo force will be acting in the upward direction, so that I can write as m into a. In addition to that, the weight of the bob will be acting downward, and also a tension force will be acting on the bob in the upward direction, that is T. Okay, so in this case, with respect to again the elevator's reference frame, if we see, the bob will be in equilibrium, and for that equilibrium to be maintained, the net upward force, which is T plus ma, has to be balanced by mg, or we can write that tension force in this case will be mg minus ma, or more precisely I can write this as T equals to m into g minus a. Okay, so as m is equal to 5 into 10 power minus 2, g is 10 minus a is 1.2. On simplifying this, we will get T equals 0.44 Newton. So this is the answer for part D. In part E of this question, it is given that the lift is going downward with a deceleration of 1.2 meter per second square. So as the lift is having downward deceleration, so that I will write as A equals minus 1.2 meter per second square. Okay, so uh, so let's note down the data first. Lift is moving downward with a deceleration of 1.2 meter per second square. Now as in this case the lift is moving downward with a deceleration, which is equivalently like the lift is moving upward with an acceleration 1.2 meter per second square. So in this case the pseudo force will be acting in the opposite direction of movement of the elevator with an acceleration. So you can just say one thing, that the pseudo force will be acting in this downward direction, and in this case this ma only the magnitude of a we have to consider. We don't have to consider the negative sign, because we have taken the pseudo force downward. Why? Because the lift is having deceleration downward. In addition to that force, mg force, that is the weight of the block, will be acting downward, the weight of the bob, and the tension force on the string will be acting in the upward direction. So in this case, again with respect to the lift's reference frame, for the equilibrium of the bob I can write that the tension force has to be balanced by mg and ma. So T is going to be equal to m into g plus a in this case. So T I can write as 5 into 10 power minus 2 into 10 plus 1.2. So on simplifying this, we will get T equals to 0.56 Newton. So in this case the tension force on the string is becoming 0.56 Newton. Okay, in the last part, in part F, it is given that the elevator moves downward with constant or uniform velocity, and that imply acceleration of the lift or of the elevator A is 0. So A equals to 0 over here. In this case, as the lift is not having any acceleration, so the only force that those are going to act on this bob is the weight of the bob downward and the tension force upward. And again for the equilibrium of the bob I can write that tension force has to be balanced by mg. So m is 5 into 10 power minus 2 and g is 10. So this is going to give T equals 0.5 Newton. So in this case the tension force on the string is again going to be 0.5 Newton. So this is the answer for this question.